Hello class, welcome to today's lesson, which is still on stage 2, kinematics and the laws of motion of the bodies. And today guys, I'm going to explain to you what uniform rectilinear motion is, and it's often abbreviated, or it's often put as URM, uniform rectilinear motion, and also uniformly accelerated rectilinear motion, which is represented by these four letters. And then I'm going to explain to you the lab practice for the stage number 2. Okay, these are very complex names for very simple concepts, guys. So let's see what they mean. So I want you to think about motion in general. Any motion, guys, can be classified into having uniform velocity or non-uniform velocity, right? Any motion on a rectilinear uh, path. Most of the times for us, motion will be um, completely over a straight line, which is rectilinear motion. Most of the times, like 90% of the times. So don't worry about other types of motion, such as circular or something. We just go either to the right or to the left, and that's it. Okay, so let's discuss each of these types of classifications: uniform velocity and non-uniform velocity. So what is uniform velocity? Uniform velocity simply means that the velocity does not change. The velocity of your particle does not change. In here I have a little table. This row represents the time, and let's suppose it's measured in seconds. And this row in here gives you the velocity in meters per second of a certain particle. You may imagine that a car is traveling on a straight path, and at every single time, like time equals 0, time equals 1, time equals 2, at that precise second, you're actually measuring the velocity of this car somehow. So uniform velocity means that the velocity does not change. As time goes by, passes by, the velocity keeps always the same. It's gonna be the same number. Let's suppose it's 2 meters per second. This is just an example, obviously. So this is the simplest type of motion, guys, because nothing really is happening other than your particle going smoothly with constant velocity. How does that look? It looks in this way, pretty much. Okay, look at this. The velocity of this car is, in particular, 1 meter per second. And so this is uniform velocity, right? It's always traveling the same distance in the same amount of time. That's how it looks. Now, the most interesting type of motion, and much more complex than this one, is non-uniform velocity. Most objects that you deal with in your everyday life have this type of motion, non-uniform velocity. They change speed, or they change velocity all the time. Nothing in nature really moves like this if you leave it on its own. Like, not really. It's very hard. Let's just say it's very hard to observe this type of motion in everyday life. It's very hard to observe it. So this is the most usual non-uniform velocity, which means that the velocity of the particle changes. And that can happen in two ways, guys. That can happen in two ways. The first way, look at this table. Same idea. We have the times in the upper row and the velocities of a certain object in the row below it. Okay, so at time 0, we have a velocity of 0. Fine. At time 1, we have a velocity of 1 meter per second. So right away, we can immediately see, just by these two pieces of information, that this means that the velocity changed, because from time 0 to time 1, the velocity already changed. It did not stay constant like in here. Can you see? Now from second 1 to second 2, the velocity changes again, but it goes backwards. Can you see? It goes from 1 to 0. So in here, the velocity increases by 1, and from here to here, the velocity decreases by 1. And then another second goes by, and now the velocity increases by 2 in 2 meters per second. At time 3, we have a velocity of 2 meters per second, and then at time 4, we have a much greater velocity than all of the rest, which is 7. So this is very, let's call it very chaotic motion, or yeah, I mean, it's kind of like random motion. Okay, so you accelerate, then you decelerate, then you accelerate again, and then you accelerate even more. The jump from here to here is much greater than the jump from here to here, which is just 2 units, and then here 5 units. So this motion is accelerated motion, right? Because the velocity is changing. Remember that acceleration means that the velocity is changing, but this is known as non-uniform acceleration. Why? Because the change in velocity is not always the same as time goes by. So in order to understand this very well, let's look at this motion now, this other type of motion. So as you can see in this table, every single second that goes by, the velocity is changing also. It's becoming greater and greater, but always in the same way, by the same amount, which is 2 meters per second. At time 0, we have 0 meters per second. At time 1, we have 2 meters per second. At time 2, we have 4 meters per second, and so on. So there is always an increase of the velocity, but always by the same amount, which is 2 meters per second. And this is what we know as uniform acceleration. And that means that the velocity changes just like in this case, but it changes by the same amount each second. Now, how does this look? This type of motion and this type of motion. Let's see. The first type of motion that I showed you, which was kind of chaotic or non-uniform acceleration, looks like this, guys. I had already showed you this animation. As you can see, the car stops at this point and at this point. Observe how it stops. 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 You see? So the velocity it goes to 0 and then it goes to 0 again. Like the velocity is 0 right here, and then increases, and then it stops again. It goes to 0 again, and then it increases again. So you have basically changes of velocity, but they are kind of chaotic. You go from 0 to a velocity which is different than 0 to 0 again, and so on. So this is non-uniform acceleration. The car is changing the velocity in a non-uniform way. And the other type of motion, which is uniform acceleration, is this. Okay, what are we having here? We have the statement that the acceleration of this car is 1 meter per second squared. And what does that mean? What's that mean? I'm sorry. That means that the velocity of the car changes by 1 meter per second each second. So look at this. The velocity is changing. The car is speeding up. But every second, the velocity changes just by 1. And ignore the last part. Like right there. Ignore that part. Just focus on the first part of the motion. Velocity is 0. And then 1 second goes by, and then you have this. Another second, and you have this. Another second, you have this. Another second, you have this. So the velocity is changing always 1 meter per second each second, and therefore this is uniform acceleration. The acceleration is not changing. So those are the concepts, guys. Okay, we have uniform velocity. It's a very, very simple motion to understand because it's just a smooth motion like that. And then we have non-uniform velocity, in which the velocity changes, and that can happen in two ways. Non-uniform acceleration, like your particle just going like increasing velocity and then stopping, and then increasing again, stopping, and then a lot, it stops, etc. It's kind of like chaotic motion. You can think of this as chaotic motion. And then uniform acceleration, in which your particle changes the velocity, but always by the same amount. Like it's gonna speed up, but always in the same fashion, always by the same amount each second that goes by. So those are the concepts, guys. I'm explaining these concepts to you because they are involved in the lab practice. You need to understand these two types of motion because the lab practice will talk about them. Okay, now in another video, I'm gonna show you what is supposed to be done in the lab practice.